Assalamu alaikum, Shabir.
Assalamualaikum.
Walaikum assalam. How are you, Shabir? Hope you are doing well and everything is fine over there.
Yeah, I'm good.
Okay, so are you ready for today's lecture?
Yeah.
Okay, have you revised your previous lecture, what we discussed about modes of transfer of heat?
Uh, yeah.
Any question regarding that lecture?
No, not really.
Okay, so let's start our today's lecture. Let me share my screen with you. So here's my screen. Is it sharing with you?
Yeah.
Okay, so let's start. Today is our lecture number 17, and in this lecture, we are going to discuss about thermal expansion. As the name stands, thermal. Can you tell me what is meant by thermal?
Heat.
Yes, heat. So, by providing heat, what would happen? Expansion would happen in states of matter. You know how many states of matter are there? Fundamentally, there are three: solids, liquids, and gases. What happens to solid, liquid, and gases when they are in contact with the heat? So basically, we are going to discuss this topic in today's lecture. Our learning objectives are: we will understand the concept of thermal expansion, then we will distinguish between expansion in solids, liquids, as well as in gases. Then we will solve some real life applications of thermal expansion. And at last, we will solve some basic problems involving the thermal expansion. All right.
Yeah.
Okay. So what is thermal expansion? How you can define thermal expansion? Simply, as I mentioned you before, thermal expansion is basically the increase in the dimension and either in length, area or volume. Can you tell me what is the dimension of length? Either one dimension, two dimension or three dimension?
One dimension.
Yes, one dimension. You're right. Now tell me what's the dimension of area?
Two dimension.
Yes, perfect. And what's the dimension for volume?
Three dimension.
Yeah, perfect. Three dimension. So here, thermal expansion is the increase in the dimensions, like one dimension, which is length, two dimension, which is area, and three dimension, which is volume of a substance when its temperature increases. So as we know that whenever we increase the temperature, there must be expansion in either dimensions, either one dimension, two dimension, or three dimension. This is known as the thermal expansion. How this happens basically? This will happen because particles gain the kinetic energy. When you provide heat to some substance, those substances gain the kinetic energy from the heat, and once those particles gain the kinetic energy, they move more energetically or more vigorously, pushing them far apart. That's why by increasing the temperature, the particle's kinetic energy increases, and if the particle's kinetic energy increases, they move more energetically, more fast. And if they move more fast, it means now your substance must have to expand. So by providing heat, you can expand substance. All substances expand when heated, and all substances contract when cooled. Okay. What
Yeah.
happens when you cool? When you cool something, the kinetic energy of those particles reduces, decreases. And once the kinetic energy of the particles reduces, their expansion would stop. Now there is contraction. So that's why all substances expands on heating and contracts when you cooled. Okay.
Yeah.
Any question?
Nah.
Okay. So let's start with the first, which is the thermal expansion in solids. You know that in solids, atoms and molecules are there. And
Yeah.
in solids, atoms vibrate about their fixed position. You have to keep remember this thing. In solids, atom must have to vibrate about fixed position. There is no random motion of atoms in the solid. In case of solids, only atoms vibrate about their fixed position, or you can say at their mean position, not randomly. So in solids, the expansion is some difficult because the atoms are tightly bound to each other. You know this thing. In solids, atoms are tightly bound to each other, right?
Yeah.
So if atoms are tightly bound to each other, so you must have to need enough amount of heat to overcome those intermolecular forces between the atoms of that solid. So in solids, atoms vibrate about their fixed position, and when you heat, the atoms gain the kinetic energy from the heat and they will start vibrating. As you increase the heat of the solid, the vibration between the atoms got also increased, and thus your solid will expand slightly. There are three types of expansion in solids. The first one is so called as the linear expansion, which means increase in length, means one dimension expansion. The second one is known as the areal expansion, which is also known as the area expansion. And as you mentioned me before, that areal expansion is also known as the two-dimensional expansion. And the last one is the volumetric expansion. If a substance increases in all three dimensions, x, y, and z, this type of expansion in solids are known as volumetric expansions. All right?
Yeah.
Okay. Here are some examples regarding the expansion in solids. Have you ever noticed that there are gaps between the railway tracks? Do you know why?
No.
There is a small gap between the tracks of a railway. This is due to avoid bulking during heat. You know, there are sunny days as well as in winter, as we remember that in summer days there is more heat, and if there is more heat, so all the substances, all the solids must expand. And whereas the railway tracks are concerned, if there is no gap between those tracks during summer days, your tracks would disarrange. So that's why there must remains a gap between those tracks, so that in summers your tracks can easily expand and do not affect the actual track of the train. Right?
Yeah.
So this is one of the application, and the second one is the bimetallic strips in thermostats, which are also used. What happens in bimetallic strips that whenever heat is more, those metallic strips expands due to the thermal expansion in solids. And the third application is metal lids loosening when heated. Sometimes the lid of a bottle, metal lid of a bottle does not open. So what we have to do, we just provide some heat to the top lid of the metal lid. And what happens, those metal lid gains heat and easily you can lose the nut. Okay.
Yeah.
So these are basically some of the applications of thermal expansion in solids. Any question regarding thermal expansion in solids?
No.
Okay. Now move on towards second, which is the thermal expansion in liquids. The same as we discussed in solids. Now the thermal expansion in liquids are more easier. But before that, can you tell me either thermal expansion in solids is easy or thermal expansion in liquids is easy?
Uh, and liquids is easy.
Yes, liquid means you can expand liquids easily or solids easily.
Expand liquids easily.
Yes, you are right. We can expand the liquid easily. Why? Because you know that in liquids, atoms and molecules are not tightly bound to each other. They already very lessly bound to each other. And whenever you provide a little amount of heat, their molecules gain the kinetic energy and start vibrating energetically. That's why expansion in liquids are more as compared to solids. Keep remember, okay? So as you know that solid expands on heating, liquid also expands on heating. The same concept, particles gain the kinetic energy and they will start moving. Okay, and we know that in liquids, particles are already less tightly bound to each other. So you only need a little amount of heat to increase the kinetic energy of the molecules. And if the kinetic energy of the molecules increases, so your molecules now expand more easily. All right.
Yeah.
So here are some examples regarding expansion in liquids. Mercury or alcohol rising in thermometer. You know thermometers. What are thermometers? Can you tell me?
Uh, they check temperature.
Yes, to measure the temperature. So in thermometer, have you ever noticed there is some liquid
Yeah.
which rises? So the liquid inside the thermometer is either mercury or alcohol. Why not water? Because the thermal expansion of mercury and alcohol is very high as compared to water. That's why in thermometers we commonly use mercury or alcohol. So these are two liquids. Mercury is also a liquid as well as alcohol is also a liquid. So thermometers are used to measure the temperature. Whenever we are going to measure temperature with a thermometer, so this liquid you notice that rises because the thermometer gains the heat from your body and the liquid rises by increasing the kinetic energy of the molecules.
Yeah.
Okay.
Yeah.
Also, you have noticed that whenever you flow, overflow of liquids from a tightly filled bottle, one left in sun, take a bottle and fill it with water and left that bottle in front of the sun. After some times, you notice that the liquids overflow from the bottles. Why? Because liquids gain the heat from the sun and the kinetic energy of the liquid got increased. And when the kinetic energy of the liquid got increased, thermal expansion starts. So that's why you notice some flow of water from a tightly filled bottle in front of sun.
Yeah.
So this is all about the thermal expansions in liquids. Any question regarding this?
Mm, no.
Okay, now let's move on towards thermal expansion in gases. So before starting this, can you tell me expansion in gases are more easier than solids or liquids or not?
Uh, they're
Means you
easier.
can it means you can expand gases more easily or liquid or solids.
Gases more easily.
Yes, you can expand the gas most easily. Why? Because you know that there is no connection of the particles in gases. The particles are not bounded to each other. They are in random position. They are in random motion already in gases. These are the properties of gases that atoms are not tightly bound to each other. They are in random motion. They are moving randomly. So by providing a little amount of heat, you can increase the kinetic energy of those particles. And if the kinetic energy of the particles increases, you can easily expand the gas as compared to solids and liquids. So the expansion in gases is the most as compared to liquid and solids, right?
Yeah.
So gases also expands on heating, okay, because the same concept particles gain the kinetic energy and they will start moving more vigorously. When heated, the kinetic energy of gas molecules increases, causing rapid expansion as compared to solids and liquids. So examples are inflated balloons kept in sunlight expands. You can blow up a balloon and put in front of the sun. You can notice that the balloon sometimes blast. Why? Because the air inside the balloon is a gas, and when the gas contains the kinetic energy by getting the heat from the sun, the gas expands, and when the gas expands there are chances that the balloon burst off. Okay.
Yeah.
Okay. Another application is explosion risk in sealed containers when exposed to heat. Some of the containers, soda drinks, contains gases inside to prevent the soda from environment. Okay, so that's why there are some gases in the containers, and if you put those cans in very high heat, in very high temperature, there are chances that the explosion happens of that sealed containers which contains gases inside. This is all due to the thermal expansion in gases. Any question regarding thermal expansion in gases?
Ah,
Okay, these are the same applications we already discussed, that bridges and railway tracks. You see that expansion joints or gaps. Why so? Because to prevent bulking in summer. Overheated wires, sometimes flag wires, you can see those wires also got very heat up in front of sun. So we must have a sag. Sag means they are left to that's more in summers due to the expansion. And in thermometers, we also use liquid expansion, like a liquid mercury or alcohol, which expands more as compared to other liquids because the expansion of mercury and alcohol are more. And also in bimetallic strips, this is one of the application. And also the important application, which is the pressure cookers. In pressure cookers, food cook more easily as compared to other cookers. Have you ever noticed?
yeah.
Yes, because in pressure cooker there is air, and air is a gas, and you put pressure cooker on the stove. Stove provides heat to the pressure cooker, and gas inside the pressure get heats from that stove. And when they get stirred, the kinetic energy increases, and when the particles kinetic energy increases, their expansion increases. And when the expansion increases, the food inside the pressure cooker can cook more faster. Okay. Hmm. So here are key points which you have to remember, that thermal expansion is proportional to temperature rise. If you increase the temperature, the thermal expansion increases. And if you decrease the temperature, if means you drop the temperature, the thermal expansion also drops. Means you can contract the substances. This is the nature of the material. Solid expands least while gases expands most. I already mentioned this thing before. Sudden heating or cooling can damage the structure due to expansion or contraction. So that's why most of the applications that you cannot have to provide much heat suddenly, as well as you also not have to cool the substances suddenly. This would happen your structure damage. Okay.
Yeah.
Mhm. Here is a work examples. How can you solve a problem related to thermal expansion? A metal rod. So can you tell me this is thermal expansion in solids, liquids, or gas? A metal rod.
Yeah. Solids.
Yes, solids. So a metal rod is concerned. A metal rod is originally 1.5 meters long. So this is the original length of a metal rod, right? 1.5 meters.
Yeah.
So here you can see in given data, the original length is 1.5 meters. When heated, now you are providing heat to the metal rod. Now what would happen to the metal rod? Can you tell me when you provide heat to a metal rod which is 1.5 meters long? What happens to that metal rod when you provide heat?
Uh, will it heat up or expand?
Yes. Uh, does it expands or contracts?
Tracks probably.
Does the metal rod expands or contract?
Expands.
Yes, definitely expands because you are providing heat. Whenever you provide heat, metals expand. So here you can see it expands by a ratio of 0.03 meters. This is the original length of the metal rod, and when you provide it heat, your metal rod expands by 0.03 meters. So here you can written as increase in length, which is denoted by delta L. Delta means change in length. Okay, this is the symbol of delta, and this means change in, right?
Yeah.
The change in length is 0.003 meters. So what you have to find, you have to calculate the percentage increase in the length. So how much length is increased in terms of percentage? You have to calculate this. So here is the formula, simply percentage increase in length. What you have to do, you have to divide the original length with the change in length multiplies by 100, because you know that whenever you are finding the percentage, you must have to multiply your number with 100 to get the percentage. Simple formula is you have to divide your original length of the metal rod with the change in length, which is delta L. So the change in length in the metal rod is 0.03 meters and the original length is 1.5 meters. Just divide and multiply it by 100. So here you will get 0.02 multiplies by 100 as it is. So 100 multiplied by 0.02, you will get your answer, which is 0.2%. So it means whenever when you provide a bit of heat to the metal rod, which is 1.5 meters, it expands, and it expands by a ratio of 0.2 percentage. All right.
Yeah.
Hmm. Any question regarding this problem?
Nah.
Okay. So here is some quick quiz for you. Can you tell me which state of matter expands the most? Solid, liquid, or gas?
Gas.
Can you tell me why?
Because the particles aren't in a fixed position.
Yes, in already in random motion.
Yeah.
Okay. So what is used in thermometers for expansion? Water, mercury, or something else?
Mercury.
Okay. Why mercury or alcohol? Why not water?
Because
Because the
that's
because the expansion of mercury and alcohol is more as compared to water. That's why. Okay.
uh okay.
Okay. Why are gaps left in railway tracks? Can you tell me?
To show when the tracks expand during the summer.
Yes,
Yeah.
definitely in summers, tracks must have to expand. So to avoid the expansion in of tracks in summer, we have to left up some gaps in the railway tracks, of course, right?
Yeah.
Okay, what happens to the size of a metal rod when heated? Either the size increases or decreases.
Increases.
Oh, yes. And when a metal rod is cooled, its size increases or decreases.
Decreases.
Decreases. Perfect. What causes thermal expansion? Can you tell me?
Uh, when the kinetic energy increases
And how you can increase the kinetic energy?
by heating it up.
By providing heat or
Yeah.
by cooling?
By providing heat.
Yes. And if you cool, what happens to the kinetic energy?
Decreases.
Oh, yes, decreases. Perfect. So these are some assessment questions for you. You can do practice at your home. So any question regarding thermal expansions topic?
Nah.
Okay, so if no, that's all for today. Take care and Allah Hafiz. Meet you soon next week.
Bye.
Thank you.
Bye.
Allah
Bye.